Hello, we're in Algebra 2, Chapter 7, Section 3. This is page 2 of the notes. We're talking E. We have this checkpoint at the top of the page. The first problem here says simplify e to the negative 3 times e to the 6. Basic exponent rules apply here, which means when you're multiplying things with same bases, no matter what that base is, the base stays the same, the exponents add. So you have negative 3 plus 6, which is 3. It's e to the third. Boom. Moving on. Number 2. Simplify. We have 4e to the third squared divided by 8e to the fifth. Well, the first thing I'm going to do, I'm going to take care of this squared business. So it becomes 16 e to the sixth. Remember that a power of a power means the exponent multiplies. In the denominator, we have 8e to the fifth, and then to finish, we'll actually divide the numbers. 2, e to the 1, but of course nobody really writes e to the 1, because why would you write 1 as an exponent? So take away the 1. But if you insist on keeping the 1, you're still right. Number 3, e to the negative 4. This one asked us to use a calculator, so find that e button on your calculator. 0.0183156389, give or take. Just what the calculator tells you. And number 4, very similar to number 3. E to the 0.36, 1.433329415. Just using the calculator. So that's all for that first checkpoint. Pretty fast. The first 2 use those exponent rules. It's a good reminder of that. The last 2, I don't know. Just calculator busy work, I suppose. Boom! Here we are talking about the natural-based functions. Okay, now this is a little bit similar to what we did in the first couple sections combined, but you want to be a little bit careful here. This time, you need that front number to be positive, and that's true for both versions, and that's still true. But since e is the base, and e is always the base, you care about the number that the exponent is being multiplied. So if the number you're multiplying the exponent by is a positive number, then it's an exponential growth function. It's a positive power of x. But if the number you're multiplying the exponent by is a negative number, that's a decay function. And I want to talk about that just really, really fast. Let's pretend you had something like y equals 2e to the negative 3x. Now, this would be an example of exponential decay because the exponent is multiplied by a negative number. And the reason why, I want to just take a moment of your time here, is the 2 is 2. That's kind of boring. But e to the negative 3x means the same thing as 1 over e to the 3x. Because negative exponent means the number gets flipped upside down. And so e is in the denominator instead. And now this 1 over e business, well, since e is like 2 point something, 1 over e is actually less than a half. So 1 over e is less than 1. And so that's why it's decay. And I left myself no room whatsoever. So I couldn't even write the 5-letter word decay normally. Oh well. That's what's going on. Now, I was trying to explain why that happened. You don't really need to understand why that happened, but it could help you not have to memorize quite so much. That's the idea, at least. Now, let's look at example 2. Here we've got some graphs, and this is where stuff gets good. Now, we're going to do A first. We're supposed to graph y equals 2e to the 0.6x. Now, it says because A equals, and they're talking about 2, which is the coefficient, and the whole point is that that's positive. And remember, you don't have growth or decay ever unless that front coefficient is positive. And r equals, in this case, the number you're multiplying x by is 0.6. That's also positive. then the function is an exponential growth function. Right? The coefficient is positive, and the exponent is multiplied by a positive number. Boom, exponential growth. Now, we can plot the points, which is like we got 0, 1, and 1 comma, and you need a calculator for this because it's some sort of decimal version with e, so it kind of stuck using calculator. You got 0 comma, I said 1, that was false, I apologize. If you plug 1 in with a calculator, it's e to the, excuse me, if you plug 0 in with a calculator, it's e to the 0, well, 0 times 0.6, which is 0. So that's 1 times 2, that's 2, 0 comma 2. There we go. So the point is actually 0 comma 2, and 1 comma 3.64. So 0, 2, 1 comma 3.64, and we're supposed to go draw a curve. Now, exponential growth, the curve looks the same. I know the e is a little strange, but the idea of the graph is the same as always. So boom, there you go. The domain is all real numbers. The domain of every exponential graph, including our friend's e, now is still all real numbers. And the range is, well, it's y is greater than 0, because we still have that same asymptote we had before, right on the x-axis, and we're right above that. All right, now that's the answer to A. Now, if we look at part B here, we know that it says A equals, and if you look at part B, there's no number in front of the E, so A is 1. There's no coefficient that you see, and so that's a positive number. And R equals, and in this case, X is multiplied by negative 0.35, and that's a negative number. The function is an exponential decay function. So again, you're got a negative number in the exponent, but a positive coefficient in front, exponential decay. So we're going to go ahead and graph this first. I know that the text doesn't tell you to graph this first, but trust me, you really want to. So if you plug in 0 into, let's see here, we're going to graph the simpler version. Y equals e to the negative 0.35x. That's not the full graph, I understand, but that's the simpler version of the graph. If you plug in 0, you get 1. And then if we plug in 1 into this simpler version of the graph, if you plug in 1, you get 0.7. So 1 comma 0.7 is there-ish, and it's exponential decay, so you know the general shape is like this. Boom. Now, then it says translate that graph. Now here we go back and look at the equation. There's an x plus 1 in the exponent, so we need to go left 1 unit, and then we're going to go down 2 units because of the minus 2. So take this graph, and remember we had dots there and there. We're going to go left 1 unit and down 2 units. So our new dot is, no, excuse me, that just looks ugly. Left 1 unit, down 2 units. Our first dot is there. And then the 1 comma 0.7, you go left 1 unit and down 2 units. It's there. And here's the key thing. The asymptote used to be at 0, right? The asymptote used to be at 0. That goes down 2 because of the minus 2. So the asymptote is now down at negative 2, and you have yourself exponential decay with that new asymptote at -2. So the domain is all real numbers. Have I mentioned that the domain is always all real numbers? Perhaps once or twice. And the range is all the numbers above the asymptote. So y is greater than -2. And that is the end of example 3. Thanks for watching.